Finally, James Webb Space Telescope launched, but the biggest question pop-up in our mind is, what we expect from NASA's James Webb Space Telescope. Is we really find out alien worlds, or we really know how Big Bang happened, or maybe solve some mysteries of supermassive black holes? These are all we find in this video, so let's start it. In Christmas Day, NASA is gifting astronomers one of the greatest presents it can give by launching the most powerful space telescope ever created. Called the James Webb Space Telescope, the Space Observatory is meant to be the successor to NASA's Hubble Space Telescope already in orbit around Earth. Sporting the biggest mirror of any space-bound telescope ever launched, James Webb Space Telescope is tasked with collecting infrared light from some of the most distant stars and galaxies in the universe. With this capability, the telescope will be able to peer far back in time, imaging some of the earliest objects to have formed just after the Big Bang. On top of that, it will unravel the mysteries of supermassive black holes, distant alien worlds, stellar explosions, dark matter, and more. NASA has worked for nearly 3 decades to craft this telescope and get it to the launch pad. Now, the telescope is finally set to launch on top of a European Ariane 5 rocket out of Europe's primary launch site in Kourou. But once the telescope is in space, there's still a long way to go. Because James Webb Space Telescope is so massive, it must fly to space folded up. Once in space, it will undergo a complex unfurling process that will take up to 2 weeks to complete. And this reverse origami must go exactly right for the telescope to function properly. All the while, James Webb Space Telescope will be traveling to an extra cold spot located 1 million miles from Earth, where the spacecraft will live out its life, collecting as much infrared light as it can. It's an extremely complicated launch and mission, with many opportunities for things to go wrong along the way. But if everything goes right, the world's astronomers will have an unbelievably powerful tool at their disposal for the next 5 to 10 years. The first thing to know about James Webb Space Telescope is it's massive. The telescope sports a light-collecting mirror that's more than 21 feet, or 6.5 meters, wide. For comparison, Hubble's mirror is just under 8 feet, or 2.4 meters, across, and it's been responsible for imaging some of the most iconic objects we've ever seen in the universe. Thanks to its larger mirror, James Webb Space Telescope will be between 10 and 100 times more sensitive than Hubble, allowing it to spot very faint objects in the sky. To assemble this massive mirror, James Webb Space Telescope engineers had to build it in pieces. It's made out of 18 hexagonal segments of the lightweight element beryllium, each one roughly the size of a coffee table. Together, the segments must align almost perfectly, moving so precisely they are aligned within a fraction of a wavelength of light, which is about 1/10,000th the diameter of a human hair. Each mirror has to match the other mirrors to a very small tolerance so that when they are aligned, they act as though they were a single mirror. Lee Feinberg, the optical telescope element manager for James Webb Space Telescope at the NASA Goddard Space Flight Center. One key feature of the mirror is that it is coated in a layer of gold about 200 times thinner than the average human hair. The gold is what allows James Webb Space Telescope to see in the infrared, a type of light that is associated with some of the most distant galaxies and stars in the cosmos. Because the universe is expanding, the farthest objects away from Earth are speeding away much more rapidly than objects that are nearer to us. The faster they sprint away, the more their light gets stretched, shifting away from the visible part of the spectrum and toward the infrared. With its gold mirrors, James Webb Space Telescope should be able to see the infrared light from galaxies that has crossed 13.6 billion light-years to get to Earth. And that's what makes the telescope a window into the past. Light from objects 13.6 billion light-years away will have taken that many years to reach the telescope's mirror. Since we think the universe is roughly 13.8 billion years old, that means these objects were around just 100 to 250 million years after the Big Bang. Even at this faraway distance, heat from the sun is still an issue. To stay extra cool, James Webb Space Telescope is equipped with what is known as a sunshield. It's made up of 5 ultra-thin layers of a material called Kapton, each the size of a tennis court stacked on top of each other. The outermost layer will always face the sun and reflect most of its heat, operating at a scorching 230 degrees Fahrenheit. But each successive layer will be cooler and cooler so that James Webb Space Telescope instruments stay nice and cryogenic, operating at about -370 degrees Fahrenheit. This decision made building the spacecraft way more complex. The massive mirror meant that James Webb Space Telescope had to launch folded up since no rocket available was big enough to house the spacecraft in its final configuration. And the truth was the technologies needed to make the telescope a reality, such as the system and mechanics needed to perfectly align those mirrors, still needed to be invented. Initially, astronomers hoped to launch James Webb Space Telescope sometime between 2007 and 2011, for an estimated cost of anywhere from $1 billion to $3.5 billion. But over the decades, James Webb Space Telescope costs continued to grow, while its launch date was pushed back and back. Eventually, lawmakers proposed canceling the project altogether over the snowballing budget. NASA then did a complete replan of the mission in 2011, and Congress agreed to continue funding the project while placing a budgetary cap on the telescope's total life of $8.8 billion. A new launch date was set for 2018. But costs continued to increase while development stalled. Meanwhile, as engineers began piecing the telescope together and testing it to get ready for space, there were all sorts of issues. Eventually, in 2018, NASA settled on a final cost for the program, a whopping $9.7 billion to cover both development and the spacecraft's operations in space. The agency also admitted that it wouldn't be launching that year. The spacecraft has taken so long and cost so much to build that everything has to go right. Otherwise, the risk is a $10 billion telescope that's dead in space. There are no mistakes that are small on Webb that have small consequences. You have to be near perfection. As of now, James Webb Space Telescope is set to launch on December 25. Its ride to space, the Ariane 5 rocket, has been Europe's premier rocket for roughly the last 2 decades. In addition to being a highly capable rocket with a strong launch record, the selection of Ariane 5 also brings NASA's European partners into what is considered a truly global mission. The launch itself should last roughly 26 minutes before James Webb Space Telescope separates from the Ariane 5 rocket. While rocketing to space is always risky, there's more anxiety to come when James Webb Space Telescope is actually free from the Ariane 5. Launch is really only the beginning. If all goes well with James Webb Space Telescope takeoff, that's when the 29 days on the edge, a term coined by NASA, begins. It's an ominous phrase to describe the telescope's complicated unfurling process. Once freed from the rocket and en route to its destination 1 million miles from Earth, the spacecraft will slowly unfurl and blossom like a mechanical flower. The first thing James Webb Space Telescope must do right after launch is deploy its solar panel to start gathering energy from the sun needed to power the entire spacecraft. During its next day in space, it'll deploy its high-gain antenna needed to communicate with Earth. After that, the really wild reverse origami begins. James Webb Space Telescope will change its shape and start to deploy its delicate sunshield, a process that is set to last for days. If that goes well, then the telescope will fully deploy its primary mirror. Needless to say, a lot of astronomers, engineers, and scientists won't be getting much rest until the entire thing is over. And there are plenty of moments where one failed pulley or one sticky actuator could jeopardize the future of the entire mission. But James Webb Space Telescope could be taking its very first breathtaking images as soon as this summer. For astronomers, the wait will be well worth it. This telescope will be transformational for astrophysics. We will learn things about the universe that completely surprise us, and that's one of the most exciting prospects about any time we put a big, bold telescope like this into space. We learn things that we never expected. That's it for this video. It's my first video. If you have questions in your curious mind, please do subscribe for more content like this. See you in the next video.